Question. After 3 sessions on memory, do you think we have solved it? If you said yes, I respect the confidence. You are wrong, but I respect it. Everything we covered forms, functions, dynamics describes the flow or the state of the art today. This section is different. We were discussing memory in the Age of AI Agents paper, and this section is paper's honest assessment of what's still broken, what assumptions need to be challenged, and where the field is heading next. 5 assumptions we have been quietly making, and 5 ways they are about to be overturned. Memory gets retrieved, memory is hand engineered, memory is text, memory is per agent, memory is trustworthy. Every single of those is being challenged right now. Let's go through them. The dominant paradigm in the memory research has been retrieval. You store things, you query, you get fragments back, you inject them into context. Done. Here's the problem. What is stored might be noisy, it might be redundant, or it might be completely misaligned with what the agent actually needs right now. It, think for this as an example. If you have ever built a RAG pipeline, you have felt this. The retrieval comes back, it's technically related. It's just not quite right. The shift is toward generation. Instead of retrieving stored fragments verbatim, you use them as raw material to synthesize a new specific memory representation on the fly. ComoRag and gmemory do this. They retrieve first, then generate a refined representation. MemGen goes further. It bypasses retrieval entirely, generating memory tokens directly from the latent space. Future memory systems need to be context adapted, cross model, and self optimizing, not static archives, active generative cognitive processes. Right now, almost every system in production is hand engineered. A human decides what to store, when to update, what to forget, fixed thresholds, prompt templates, and hard coded pipelines. Which is a very confident way of saying we guessed and then we hard coded the guess. That works for narrow tasks. It completely falls apart in open ended, long horizon settings, which is our ultimate goal. The direction the field is moving, memory operations becomes tool calls inside the agent's own reasoning loop. The agent explicitly decides add this, update that, delete this, retrieve now. No external orchestration. The agent manages its own memory the way it manages any other actions or tool calls. And beyond that, self evolving structures that reorganize themselves without any human design rules at all. This is, in my view, most technically significant frontier in the entire section. If you look clearly, there is a clean progression. RL free systems that were MEMGPT and Expel to RL systems such as MEMAlpha and Memory R1. They start using reinforcement learning to optimize selected memory operations. And at the frontier, fully RL driven systems where the entire memory architecture, the format, the storage schema, the update rules emerges from optimization rather than human design. That last category barely exists now, which is either exciting or terrifying, depending on how attached you are to writing memory pipelines for a living. But the direction is clear. The vision is a memory subsystem that co evolves with the agent through RL, not something bolted on by an engineer or a member, but something the agent discovers as the optimal way to remember for its specific task and environment. Two expansions happening in parallel. First, across modalities. Text memory is mature. Visual and video memory are maturing fast. Audio memory is purely explored. And crucially, no system supports today truly omni-modal memory. Unified representations across text, image, video, and audio simultaneously. That's an open problem. Second, across agents, early multi-agent systems gave each agent its own isolated memory. Then came centralized shared stores. The frontier is agent-aware shared memory, where you can read and write, depends on your role and expertise and trust level within the system. The hard problems, write contention, collective privacy, and preventing one agent's bad memory from contagion or corrupting everyone else's, and which is one of the very big points in the AI security landscape right now. Without this, the enterprise doesn't trust the AI systems or the agent, multi-agent memory systems. Trustworthy memory. This is the one that keeps practitioner up at night. Think about the last time an AI gave you the wrong answer with complete confidence. No hedging, no, I am not sure. Just wrong and certain. That's the problem at scale. As memory systems become more capable, more persistent, more personalized, more deeply embedded, three problems get worse simultaneously. First, the privacy. Memory stores sensitive, user-specific content across sessions. Recent works shows that memory modules can leak private data through indirect prompt injection attacks. Second is the explainability. When an agent gives a wrong answer, which memory caused it? What are the decision traces? Current systems have no answer to this. It's a black box. The third is hallucination. Stale or poisoned memory produces confident wrong answers. And here's what makes it worse, that no memory at all, the agent doesn't know it's wrong. There is no uncertainty signal, it just answers. Trustworthy memory isn't nice to have, it's a hard requirement for any real deployment. And if you want to scale your AI systems with enterprises, this is a non negotiable. Let me close with the most thought provoking gap in the entire paper. Current AI memory is essentially a recording device. Something happened, it gets stored. It gets retrieved verbatim later. That's it. But the human memory doesn't work like that at all. Human memory is reconstructive. When you remember something, your brain actively rebuilds it from fragments, influenced by your current state, your expectations, your emotions. It consolidates during sleep, reorganizing an abstracted experience into durable knowledge. It hardly forgets, not as a failure, but as a feature that enables generalization. We don't give our agents sleep, which honestly might be the problem. And I think one of the closest visions I've seen similar to this is Claude's auto dream feature. The frontier of AI memory points directly at these properties. Sleep like offline consolidation intervals, generative reconstruction rather than verbatim retrieval, and active forgetting as a design principle. And that's the right closing note for this entire agentic memory frontier we have been talking about. The goal is not an agent that remembers everything. It's an agent that remembers wisely, selectively, generatively, and in a way that makes it smarter over time. Thank you all for being part of this session till the end, and I hope you had a great time learning more about the frontier AI memory systems.